The last thing that we want to say about polynomial graphs at the moment is to describe what's called their end behavior. That term end behavior refers to what happens to the value of f when x is either a very large positive number or a very large negative number. To say x gets very large, we will write the symbol x followed by an arrow followed by an infinity symbol. And just like when we were writing interval notation, that's not some number infinity. It's rather just a symbol that means that x is allowed to be very, very large numbers indeed. And to make it very clear that x is getting very large positive, we will often write a positive infinity there. To say x is getting very large negative, we write an x followed by an arrow followed by a negative infinity. Again, that's not some number, negative infinity. That just means that x is becoming a very, very negative number. It's negative 73 billion or negative 73 trillion. Very large negative. And the key point to know is that when x is very large, either positive or negative, the leading term of the polynomial is the most important. Once x gets big enough, the leading term gets big enough that you can kind of forget about the rest of the terms. And that's going to be how we describe the end behavior. So if we wanted to describe the end behavior of this polynomial, first we would look at our leading term. So to find our leading term, we have to do some multiplying. We go to the leading term of each factor, and we say, okay, we've got a negative 3x times an x times a 2x times a negative x, and that's squared. So let's see. We have 1, 2, 3 negative signs, so our result's going to be negative. We have 3 times 2 as our only numbers. That's a 6. And then we have 1, 2, 3, 4, 5 x's. So it's negative 6 x to the 5th. The two important facts about this are that the coefficient is negative and the exponent is odd. We're looking at the graph of y equals negative 6 x to the 5th. Well, that's going to pass through 0, 0. It's going to be kind of flat in the middle, and it's going to be upside down because of the negative. So we've got that upside down S-shaped curve. It's going to look something like that. Now notice I didn't mark any numbers on my axes. That's because I don't want to bother figuring out what the actual points this graph passes through are, because there's going to be really big numbers involved. And all I'm actually interested in this picture is what's happening as we go off the graph anyway. What's happening as we go off the graph? Well, when x gets very, very large, that's going off the graph to the right. Our function is going down, so our function is getting very large negative. When x gets very negative, that's going off the graph to the left. In that case, our function is going up, so our function is getting very large positive. And that's what we would write to describe this end behavior. F of x goes to negative infinity when x goes to positive infinity. F of x goes to positive infinity when x goes to negative infinity. Please, please, do not make a great big table of what happens at the ends of the graph. What happens at the ends of the graph is going to be very, very large numbers. What happens at the ends of the graph is going to be very, very small numbers. What happens at the ends of the graph is going to be very, very small numbers. What happens at the ends of the graph is going to be very, very small numbers. What happens at the ends of the graph is going to be very, very small numbers. What happens at the ends of the graph is going to be very, very small numbers. What happens at the ends of the graph is going to be very, very small numbers. What happens at the ends of the graph is going to be very, very small numbers. What happens at the ends of the graph is going to be very, very small numbers. What happens at the ends of the graph is going to be very, very small numbers. What happens at the ends of the graph is going to be very, very small numbers. What happens at the ends of the graph is going to be very, very small numbers. What happens at the ends of the graph is going to be very, very small numbers. What happens at the ends of the graph is going with positive coefficients versus negative coefficients, even exponents versus odd exponents. You already know what you need to know in order to figure out the end behavior. You know how to find the leading term. You know how to do a quick sketch of its graph. You don't have to figure out the exact points, just the general shape. Is it U-shaped or S-shaped? Is it right side up or upside down? Do a quick sketch, look at it, and describe the end behavior of the sketch. When x is very, very large, the graph of the entire polynomial looks like the graph of the leading term.